Think about the last time you tried to learn a really difficult skill. Like this weekend, I was attempting to master a cheese souffle.
Oh, wow. Ambitious.
Yeah, it was a total disaster. I kept failing, and eventually I realized my problem wasn't just the recipe itself.
Right. It was your approach.
Exactly.
Yeah.
I was obsessively rewatching the exact same tutorial video. And, I mean, if your method of learning never changes, your results won't either. You can't just practice. You have to change how you practice.
That is honestly the core limitation that artificial intelligence has faced for the last decade.
Which is exactly why today's deep dive is so exciting. We're looking at a breakthrough research paper on a framework called Hyperagents.
Right, where AI finally figures out how to upgrade its own learning process on the fly. It's a huge shift.
So if hyperagents are the fix, I'm assuming the previous generation of AI, like the Darwin-Gödel machine we saw a while back.
Yeah, the DGM.
Right, that one hit a wall because it couldn't, step outside its own programming.
Exactly. I mean, the Darwin-Gödel machine successfully self-improved, which was great, but only within really rigid boundaries, like writing better code.
Okay.
The bottleneck was that the meta-level mechanism, the part dictating how it improved, was entirely hard-coded by human engineers.
Oh, I see. So it's kind of like a robotic arm holding a hammer.
Yeah,
It can figure out how to build a slightly better hammer,
yeah,
which is great for hammering nails or, coding.
right.
But if it needs to paint a house, a totally non-coding task, the fix mechanism just fails. And honestly, if your business is stuck using a rigid tool for every new problem, you're going to get left behind.
Absolutely.
Which actually brings me to this. This podcast is sponsored by Embersilk. Need help with AI training or automation or integration or software development, uncovering where agents can make the most impact for your business or personal life? Check out embersilk.com for AI needs.
So, moving past the hammer analogy, how do hyperagents step off that rigid assembly line and actually change their own machinery?
Well, they do it by fundamentally changing their architecture. They merge the task agent, the part doing the actual work.
Yeah, exactly. They merged that with the meta agent, the part directing the improvements, into just a single editable program.
Wait, really? Just one program?
Yes, because both the task and the improvement instructions are written in the exact same language, the AI can treat its own underlying improvement mechanism as, well, just another piece of code to analyze and rewrite.
Wait, let me challenge that for a second. If a system is constantly rewriting its own brain's operating system while it's running, wouldn't it eventually corrupt itself?
That's a huge concern, yeah.
Like, how does it avoid optimizing for the wrong thing entirely and just completely breaking?
That is the exact risk of what researchers call metacognitive self-modification. But the paper detailed something amazing. The hyperagent actually autonomously developed a safeguard to prevent that corruption.
Oh, it fixed the problem itself.
Yes. Because it wasn't limited by our human architectural assumptions, it built its own system for persistent memory.
And that's not just logging raw performance numbers,
Yeah.
right? It generated qualitative notes.
Exactly. It stores nuanced insights.
Yeah, the paper showed it leaving notes for itself, like Generation 55 has the best accuracy, but is too harsh. That is fascinating because it mimics human intuition.
It really does.
It's creating this nuanced diary of mistakes so future iterations don't repeat them.
Precisely. And structurally, that persistent memory allows for something truly profound, which is cross-domain transfer.
Oh, taking skills from one area to another.
Right. The paper demonstrates that hyperagents optimized on, say, reviewing research papers and designing rewards for robotics could take those exact self-improvement strategies and successfully apply them to grading Olympiad-level math.
Wait, Olympiad math, just from robotics?
Yeah.
That architectural leap is incredible. I mean,
Yeah.
seamlessly applying that means the AI understands the actual concept of problem solving, not just the specific subject matter.
Exactly. It's learning how to learn.
The implication for humanity here is just incredibly optimistic. I mean, this could transform scientific discovery from a human-paced crawl into a self-accelerating sprint. It gives us the tools to rapidly solve our greatest scientific mysteries.
It absolutely points to a future of compounding progress, which, leaves you with a really interesting thought experiment to mull over.
Oh, what's that?
What if the ultimate technological breakthrough isn't an AI that solves a specific scientific problem, but an AI that invents a completely new, fundamentally non-human way of thinking about problems altogether?
Wow. That is a brilliant way to look at it. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.